Hi, I wanted to do this video to just capture my experiment with Apache Spark and Hadoop on the Google Cloud Platform. I The reason I'm doing this is twofold. One is to have my own sort of a live video documentation of my work, as well as I just wanted to see how it turns out, given that I'd never done a video before. It's my first time doing it, so I just wanted to see how it would come out. So I'm leveraging Google's cloud platform for my experiment. I'm going to my account here. This is the dashboard for my account, and I'll go to the under big data. There's a service called Dataproc, and so Dataproc is their Google's platform as a service for Apache Spark on Hadoop. So I'm leveraging that environment because it gives me a quick way to spin up a Hadoop cluster and have Apache Spark running on it. My main focus of the experiment was to was to get going with doing the data analysis and using the functionalities of Apache Spark. So one way that I could spin up the cluster is create it from the GUI interface here, or I could, what I did was I used Google Cloud SDK tool. They have an SDK for interacting with the command line API. So that's what I use. So that way I can script it up and automate the deployment along with deploying my scripts for a couple of the experiments that I tried. Okay, I'll delete the files here and copy it fresh. This is my main script that provisions the Hadoop cluster environment for me, and also does some automation to prepare the environment for my experiment. So I'll go through the script in a little bit detail. Let me kick it off because it takes about 2 minutes for the cluster to provision. This is a shortcut alias I have that fires this script. It's running now, and on the dashboard it should show that the cluster is getting provisioned. There it's so there's the status showing that it's provisioning, and yeah, it's going to run for a little bit. So while it's running, what I want to do is go through quickly some of the steps that this script is going to run for me. Alright, so I'm going to do a couple of experiments. So the main experiment that I'm doing is I'm bringing in a live Twitter feed based on a keyword filter. Any word, like I could choose US Open or any live event that's happening. Like one time I was doing the Belgian Grand Prix Formula One race, so that was a good live event that was going on when I did the test. At other times, I just use a word that I know that's frequently been talked about, like for example Trump. So for this experiment right now, I probably do it with that keyword. Trump, just because I'm not sure I'm aware of anything that's happening right now that's being talked about a lot. So having said that, so that experiment with the Twitter feed, I'll be bringing in live streaming it using the live streaming API. And there are three types of experiments I'm going to do with that data using Apache Spark. So one is to look at the top ranking hashtags, top ranking in the sense the most repeated hashtags in that Twitter stream. Also look at build a word cloud, a graphical display showing the most frequent words in bigger font in the display. And n-grams is basically taking two-word phrases or three-word phrases. It's called the two words could be called bigram. 3 words is trigram. So just to show, like in a contextual sense, as a phrase, what are the top phrases that are being used often in the Twitter realm. So that being said, the provisioning of the cluster is happening with this piece of code right here. So gcloud is a cloud SDK command line call to the GCP interface to build the cluster using Dataproc as the platform as a service that's there. And this cluster is being provisioned with 2 worker nodes. It states here, each worker node having 2 vCPUs, and the master node also has 2 vCPUs. And it will also, I'm instructing to download Miniconda, which is Python's data science, data analysis type packages that has like NumPy, SciPy, pandas, and also I'm initializing Jupyter Notebook, the service, and I will be running the Spark analysis and the interaction with the script as well as the output on the graphical display. It will show on the Jupyter Notebook. So that's the gcloud command. It's still running, building the cluster. The rest of the steps are what I do to just promote my the experiments that I'm doing, the scripts for that, right? So first I source some information once the cluster is built about the private IP of the cluster, the GS bucket, the Google storage bucket that it'll provision for me, and then I'm using that in my script to I have some placeholder variables in the scripts that need that information, so I'm feeding that information into the script, substituting it with the actual values, and I'm promoting it to the cluster. So here it's remote SSHing into the cluster master node, creating my folders for this to hold my scripts, and populating some environment variables for me to have some shortcut commands I can run. So I don't have to type out the whole command. I can just type one key and it will take me to the right folder, or it will run a script for me, that kind of stuff. Iterating over each value, each value of my app, the experiment. The information is stored here in a shell array, and I'm preparing the scripts for each of those experiments, because each experiment has its own set of scripts. So I'm using the information from the cluster to populate the variables that I mentioned into each of the scripts there. And then I am remote SSHing over to the master node, and I'm downloading some Python packages such as Seaborn, which is used for graphical to make graphs look prettier, runs on top of Matplotlib. Natural language toolkit for natural NLP type of processing. Tweepy to connect up to Twitter streaming API, word cloud to show the enhanced display of word cloud, and basically big font for the most repeated words. And the next steps I'm doing is I'm just remote SSHing into each of the worker nodes of the Hadoop cluster, and installing basically the NLTK for natural language processing tasks that'll run on the worker nodes. And then I'm at the end outputting some helpful commands to a text file, so I can just have them all in one place for copy and pasting into my command line. Alright, so let's see if the cluster build finished along with all the steps that I was talking about. Yeah, so it installed my packages, moved the scripts in place. Yep. Alright. Okay, so what I did in the last couple of steps is to open up a SSH tunnel, a SOX5 proxy tunnel, to proxy my traffic of a Chrome browser session to talk to the services that are running on the Hadoop cluster. So that's the yarns, the resource manager for Hadoop, the interface. There should be two worker nodes. Let's see. Yeah, there's two worker nodes, worker 1, worker 0, and then the applications. There's no applications running right now. Let me open the Jupyter Notebook interface. Okay, so these scripts got transferred as part of my provisioning and the automated deployment that I wrote. Alright, so let's initiate the experiment, the first experiment. And then I'll explain a little bit of what I'm doing with the script that is running as part of the experiment. I'm SSHing onto the master node of the cluster. Okay. Oops. So I'll go over a little bit of what the script is doing. I just wanted to kick it off for the first experiment. So what the display is showing are the top 10 hashtags that are happening real time in Twitter for the keyword Trump. Like I said, I'm not aware of any particular events happening at this time that I could do the analysis on. So because if there's no live event going on, because this is live streaming, and I just put the word in, usually there's not a high volume of tweets that I'll get, and the experiment is not going to be not successful, but it's not going to be meaningful for showing it. So, but on the keyword Trump, there is always, any time of the day, you're guaranteed to get a high volume of tweets. So that's the reason why I wanted to, just for demonstration purposes, use that. All right, so this chart is updating every 6 seconds or so as the stream is coming in, as the live streaming data is coming in from the Twitter streaming API. So as the data comes in, it gets posted to a TCP socket, and then Apache Spark consumes it from the socket and distributes the map and reduce functions for the data analysis, the text parsing, and the counting up the number of times a word is occurring. So that aspect of the data, data manipulation and data processing is happening on the executor worker nodes of the Hadoop cluster, and Spark is basically issuing commands through Py4j. I'm using PySpark, not Scala. So using Py4j to talk to the underlying Spark core, and in each of the functions for the text parsing, the transform functions are running on the executor worker nodes, except for when I run a group by count the summation of the number of times a word appeared. It's like a group by statement in SQL. That part, the data is probably shuffling between the worker nodes, and at the end I'm pulling the data back into, which is called an action step on Spark, in the Spark paradigm of how the program functions. The action step brings the final results back from the worker nodes to the driver program on the master node, and prepares it for output to either a table in the database or to a text file. In my case, I'm uploading it to a temporary view, like a table in memory, and then outputting and querying it using Spark SQL to show this display, the chart. Alright, so let me stop this one here, and let me do one more experiment before I go through the script. I'll run the word cloud as the next one. Stop it. Let's kill this session. Let's run word cloud. Okay, so let me run the experiment for word cloud, and let me paste it here. Yep, this will run the word cloud for me. Let's kick it off. So there's the word cloud display on the left window there. The word cloud, I had it, I believe, refreshing every 12 seconds, whereas the hashtags was refreshing, the chart was refreshing every 6 seconds. I believe I did that for 12 seconds is because just wanted to get, I'm counting, I'm using about 100 words to build the word cloud display. So just to build up enough data to have 100 keywords, I just had a little more gap between each refresh. Alright, so let's look at the first script of hashtags. So the hashtags, the word cloud, they're kind of similar in what the work that's being done. So I'm just starting with the hashtags. I think one is enough to go through it. What the This is using PySpark, and I'm connecting up to the socket that the data is being posted on from the feed script. In fact, let me actually review the feed script first. So the feed script is the one that connects up to the Twitter API. So Twitter has a streaming API and a REST API that lets you search prior tweets, past tweets, but the streaming API is a push type of framework where as long as you have a session connected to the Twitter streaming API, it will push all the messages that you're filtering for. You do have to provide at least one keyword to query the streaming API. You'll have to have a developer account, Twitter developer account, to get the credentials to connect up to Twitter API. So that's what I'm sourcing here as OS environment. So my Twitter credentials got promoted as part of the provisioning of the cluster, and when I promoted my scripts, I actually sent over a file that has my Twitter credentials in key value pairs, and I appended that file to my .bashrc so I could recall those values from my script here rather than hard coding those values, because you wouldn't want to hard code like password, secret type of information within a piece of code or even in a configuration file. So it's one of standard practice people use to get secrets. Just put in an environment variable and recall it within a script, so it doesn't have to be in any file. And also because it changes from environment to environment, so it makes sense to put it as part of as a function of the environment, and also because of just plain security from keeping it out of plain sight. So for the feed, I'm using Tweepy, which is a Python package, like I mentioned. Tweepy has two classes. One is the stream listener, and the other is the stream. So the stream listener has a method called onData that actually gets the data and posts it to the TCP socket, and the stream object uses your authentication credentials, my Twitter API credentials, to establish the session with Twitter API. So let me look at the bottom of the script here where it begins. It creates the socket with the connection. This is the private IP, the port, and it creates the socket and sends that socket information to send data function, and send data with my collects the user information, the Twitter API credentials, and posts it to stream by sending the incoming tweets, which is an instance of not instance, but it's a class inheriting from, well, this is an instance here of the class incoming tweets, which inherits from the stream listener of Tweepy. So the method of onData will post the data as it comes in to the socket after converting it to UTF-8. Now, I didn't completely write the script from scratch. There's plenty of examples on the internet, very similar. It's out there on the internet. TWIP is a very popular package to interface with the Twitter's API. So it's already out there for whoever wants to look at. Now I did add a couple of lines here and there. For example, not in the hashtags, but let me show you. I think the word cloud might have it. Yeah, so in word cloud, what I did was, Twitter has retweets, right? So retweeting is retweeting someone else's tweet. So at one time when I was doing the analysis, I didn't want to see the text that's being retweeted because it's not really original, and I just wanted to look at only the new first original text that's coming out as tweets, and analyze that. But then I actually commented this line out. This is where I was doing it. I commented it out because it actually defeats the purpose of looking at the frequency. So if there's a frequency of something I want to observe, I would want to see the retweets as well, because retweet is basically echoing the same sentiment. So it does make sense to actually count up the retweets as from a frequency observation, because it's the same thing that other person wants to say or to support, right? Yeah, so that's pretty much it, and then it posts the data like I mentioned, right? Let's see okay, so that's the feed, bringing in the feed, posting it to the TCP socket, and here is the PySpark Spark job that's running, that connects to the socket, downloads that to dstream. Apache Spark has a newer API that actually came up where you don't have to use dstreams, and also RDDs, which is resilient distributed dataset. So in this script, once the data is received from the socket, it posts it to the dstream, and the dstream, each one of these are actually producing a dstream, a transformed dstream. Each one is a transformation step here, and the transformation steps are running independent of each other or running in parallel on each of the worker nodes. So and it's all running in memory. Anything in Spark is pretty much run in memory, unlike in Hadoop. MapReduce functions in between a significant batch processing of a MapReduce, then it will post it to, I mean not post it, but it will save it to disk, and the next batch would read it from disk and run its next set of operations. Well, the advantage with Spark is everything is chained here, and all of it can run in mem. So so here it's taking each of the lines, splitting them up using a space. Actually, it's splitting them up using multiple spaces if there are. It's converting it to single space as a delimiter. And I added that. Now again, this script is also out there online. You could find, there's lots of examples out there. When I'm learning something from online, I take what other people, the best of the examples, take what other people have written, so I don't have to reinvent the wheel, and then I add my own as I'm going along and understanding and learning. So the next step here is it's splitting up each of the it's taking the lines, splitting it out into words, and then taking each of the word, converting it to lowercase, and then taking each and filtering out any word that doesn't start with the hash symbol, and just takes the words that start with hash symbols, because this is for hashtags. Only looking for the words that start with the hash symbol, and then I'm looking for any word that doesn't have, or any hashtag without the hashtag for Trump, because my keyword filter was Trump, so it's obvious that Trump will be there. So I want to see other words that are associated with that keyword, not the keyword itself. Filter out any word that's less than 20, filter out anything that's more than 20 characters. So I want it up to 20 characters, because I've seen some junk characters that are in there, or junk words or hashtags that are very long, and I don't know how it gets in, whether it's a system problem or somebody playing with it, just fooling around. and then I'm associating the word, the numeric one to each of the word, so it can be counted up like in a group by sum function. So this is the group by sum taking place. This is a reduce function. Whenever there's a reduce function running, it will shuffle data between the worker nodes. So it's not, not recommended if I want to avoid, it is an more expensive operation than each one of the previous ones, because all of the previous ones can run independently and it doesn't need to talk to each of the worker nodes, each of the other partitions to assimilate data. Whereas here, reduce by key would have to do that. But obviously, if you have, but it all runs in memory, so it's very fast still. And then once that is done, I basically what I have at the end of this RDD step is I have an RDD with word and the total number of times the word repeated, right? So I'm casting it to a tuple called hashtags that has tags as one of the first field. A second field is the count, right? So that's what's happening here, and then I'm posting that data to a data frame, again, not the pandas data frame, but Spark's data frame, and then doing a sort by count descending. So I see the top 10 most repeated words and the top part of the output. And I'm taking only 10, like it's a top 10, right? And then I'm taking that output and posting it to a temporary view in memory. It's like a table called tweets. And then at the end of the script here, so this part here initializes my charting environment. So the charting display is taking the matplotlib and the seaborn to make the chart look prettier with the colors and how the bars appear, giving it some information on the font size, the font weight, the label size and whatnot to make the chart look the way you'd want to, right? So that's related to the charting aspect. And then I'm using IPython's display to display the chart, and then I'm looping over. That gives the effect of the chart updating every so many seconds. So I sleep for 6 seconds. So every 6 seconds the chart is updating. It's selecting the values, the tags, the count from the tweets, the view table there, and then it's casting it to two pandas, which is just back to the data frame again, and then using the data frame, putting it onto the matplotlib through Seaborn to then do the chart, a bar chart. So it's a bar plot, right? So that's pretty much it. I didn't write this script from scratch. It's out there on the internet, as well as some of the stuff that I did. I did add a few of my functions here and there. I also added, not in hashtag, but in word cloud. I added a Python function that does some additional work. I'll quickly show that as well. Let me get out of here. Home, word cloud. Yeah, so in word cloud I run this function that takes out the stop words and the punctuation. So the stop words is from NLTK, natural language processing, and the stop, yeah, like I mentioned earlier, some of the ordinary English words, they're just prepositions and this, that kind of stuff is taken out, as well as the punctuation symbols, the punctuation characters are taken out. So I'm just, instead of doing it here, I added it all up down here. In a function, wrapped it up in a function, and return the text, which is all that I don't want. So then in here, I just said not in filter words, right? Words that are not in filter words. So no filter words. No, sorry, filter words is another one, another list actually, and it just has Trump here for now. But I could have added more. Like if I don't want to see Donald or president, which is obvious with Trump, then I could add here Donald and president, and those won't show up in my, those words won't be considered either. And the get words is the call to the to the function here that is running, right? And there's some others. Let me quickly look at the ngrams one. Yeah, ngrams also. Yeah, ngrams also. Yeah, so I'm running the bigrams by taking the text and splitting it up into sentences separated by a period. Right, and then sending that line of text to this function here, get phrases. So I want 2-word phrases because it's a bigram. If I wanted 3-word phrases, I would put this would be trigrams. So NLTK package has this, which really, like I actually wasn't aware that there was bigrams and trigrams. I thought of it as I was doing the experiment that it'd be nice to, instead of looking at a single word out of context, maybe if I can get the word and the next word, or 3 words. My initial intention when I was doing this, and the thought came to me, was it would be nice to have 3 words from the tweeted text, because that would impart a meaning, right, and would give some contextual meaning. And if I can find other people repeating that text, then that really is a significant meaning that it would that I can extract from the tweets. So when I started researching, I was actually writing a Python function to break that text, the tweeted text. Once I took the delimiter of the period and then took the sentence, I was writing the Python function that would do that, splitting up that sentence into 3 words that are coming next to each other. And when I was doing that, I actually wrote most of the function, and I realized, I saw as an example, someone mentioned, well, that's what you use bigrams and trigrams from NLTK, which is Natural Language Toolkit. So then I said, oh, okay, there you go. That is a high-level function. Somebody already wrote it, and it's already there. So then that's this encapsulated that entire function. It just does 2 bigrams of tokens, and tokens here is is a single word that's coming out of this, and the single words that are coming out here are those that are not in cached stop words. So I do take the stop words out still, which probably is not a smart idea, because like I said, I mean, like I'm looking for a phrase. I wouldn't see 3 nouns next to each other. I would see it in a context of a verb, an adjective maybe, and that. So that, I mean, I shouldn't have, if word not in cache stop words, I should probably take that out and run it without that. So that was a misstep here. And yeah, that's pretty much it. And it does the same analysis, then posts it to the for charting. Yeah. So that's my dive into using Spark with Hadoop, and my experiment. So hope you enjoyed it, and thanks for watching.